Welcome to the integral test for series, take 5. Okay, so students are going to demonstrate this, but actually I'm going to demonstrate and to show you if a series diverges or converges based on using the integral test for a series. A couple things you're going to need to know for this video: how to integrate improper integrals, how to complete the square, and unfortunately in this test it won't tell you what we converge to. This test will only tell you if the series converges or not. So a couple things we want to be careful of. The function f of x must be continuous, positive, and decreasing function. Those three things, okay? You might need to use the first derivative test, f dt, in order to show that the function is decreasing. Most of the time you might be able to tell, but it could pop up. I don't think it will in the BC exam like that, but you never know. So here's the kind of the meat and potatoes of this. If f of n equals a sub n, so if some function in terms of n is a sub n, then that series is going to converge if the improper integral converges. So the idea here is that if I can show the improper integral converges, it's going to mean that the sum is going to converge. That's what it implies down here. That's what we're looking at in red. Okay, so I'll just move so you can copy that if you need to. So we've got a couple of examples to show you. Whoops, off the chair. Example 1, does the sum n over n squared plus 1 converge? Write the improper integral first. So here's my sum, there's my a sub n. So improper integral 1 to infinity of x over x squared plus 1 dx. So here's the definition in red of an improper integral if we're going to take its integral. The limit as b approaches infinity of the integral 1 to b of x over x squared plus 1 dx. Now I'm going to integrate this, and I'm going to use u substitution here. I'm going to let u equal the denominator. Du dx equals 2x, and that means dx equals du over 2x. So there's my substitution. My x's are going to simplify to 1, and in red is what all of this was right here. I just put that here, and I have the limit as b approaches infinity of the integral 1 to b of basically du 1/2 du times u. So I'm going to bring the 1/2 out front, so the limit as b approaches infinity of 1/2 the integral from 1 to b du over u. So I integrate now, which is 1 over u, and you integrate is natural log. So I have the limit as b approaches infinity of 1/2 the natural log x squared plus 1 evaluated from 1 to b, and I've done that here, and I substitute it in b, and I'm going to subtract off when I substitute 1 into my answer. So the limit as b approaches infinity of this is going to infinity, because if I ignore here and I plug in a very large number for b, it's going to infinity. That means that this improper integral diverges. Well, that means the sum of n over n plus 1 is going to diverge as well. Next example. The sum from 1 to infinity of 1 over n squared minus 4n plus 5, does that converge or diverge? Now, I rewrote the problem here. Is the function continuous? It is, okay? And you can look to try to factor. We can't factor that function. We're going to actually complete the square. So again, I set up the improper integral, okay? 1 over x squared minus 4x plus 5 dx. And then there's the improper integral limit, okay? Limit definition. Okay, so limit as b approaches infinity of 2 to infinity of 1 over. Now I've changed this denominator, and I've completed the square. So I'll move, and so you can just look. So I completed the square. You want only the n terms on one side. You take half of the n term, square, which is that where that plus 4 comes from. I moved the 5 over and I added 4, because if I add 4 here, I'm going to add 4 here. Okay, so I get n minus 2, that quantity squared equals negative 1, and I bring the 1 over. The denominator is not going to equal 0. This is always going to be positive, and if it were greater than 2, we're always decreasing. Okay, so that's where this 2 comes from in switching that out. And there's some other algebra behind the scenes there. I don't have time to talk about that, but you can ask below if you're not understanding why we go 2 here instead of 1. But the function is decreasing when n is greater than or equal to 2. So let's look at doing a little more math to fix this, okay? Now, I'm going to let u equal x minus 2. So there's the x minus 2 squared plus 1, and du equals dx. Okay, so I'm taking the limit now as b approaches infinity. When you take that derivative, or that integral, okay, guess what? It's inverse tangent of x minus 2, okay? And I'm evaluating that from 2 to b. Okay, so now I have to think about, well, what happens when b gets really, really large if we go this way? So what I've done is drawn a graph of inverse tangent. And look, if inverse tangent, if the value of x gets really, really big, we're going to limit to pi over 2. So my improper integral is actually going to limit to pi over 2, and I use this graph to help you to see that, okay, going this way. Since that limits to pi over 2, that converges to a number, that means my series converges. Okay, so that's 2 examples on the integral test for a series. So if you have any questions or comments, you can type them below. We'll see you next time.